Hi there. I know a lot of us are used to multiplying in a certain way, and the way math is now, they want kids to understand it in several different ways. I just wanted to go over one of the ways that might look a little bit different from what we're used to, from what we've grown up doing. Let's say we're doing 4,364. And we're doing that times 6. What we're used to doing looks like this. We go 4,364. We put the 6 underneath that 4, put our times sign, make a tally line. And then we do our typical algorithm, which is take our factor and multiply it by every single place value. Anytime we have a number that's 2 digits, we regroup that tens digit to the next place value. So 6 times our ones place gives us 24, and instead of writing 24 like this, we write the 4 down and regroup the 20 to the next place value. 6 times the tens place is 36, plus the 2 is 38, so we're going to regroup that 30 and keep the 8. 6 times 3 in the hundreds place is 18, technically 18 hundreds, but since we've got two things here, it forces it to be in the hundreds place. 18 plus that 3 is 21, so we'll regroup the 20, keep the 1. 6 times 4 is 24 in the thousands place. 24 plus 2, 26. I think that's the algorithm we're all used to. What I'm showing the kids is slightly different, and what I'm telling them, this is definitely what we want to do, but this is technically a shortcut method. This is good because it's shorter than writing out every single step, which is just at the moment what we're practicing, because it's going to help us when we do 2-digit multiplying. So what we're doing right now is something a little bit more like this. 4,364 times 6. Still looks the same. But when we do our 6 times our 4 in the ones place, we just write down that 24. Then when we go to the 6 times the 6 in the tens place, we say 6 times 6 is 36. It's in the tens place. That means our tens needs to have a 0 before we write that 36. 6 times the 3 in the hundreds place is still an 18. Since it's in the hundreds place, hundreds need 2 zeros, then I can write my 18 and I've got 1,800. Finally, 6 times 4 in the thousands place, that's a 24. 3 zeros for our thousands place, 24,000. And then we put all that stuff together. 4, 8, 11, regroup just like normal addition. 1 plus 1 plus 4 is 6, and a 2. And if you compare, it's absolutely the same thing. Now, as an adult, we'd say, why would we do this? We wouldn't. We would not do this method if we wanted to just get done. We're doing it with the kids so that they can see. When we regroup, it's a shortcut for writing out this 24. This 24 would be in the way when I get to my 360, because this 6 and this 2 would occupy the same space. All we do when we're regrouping, really, is taking the 2 and moving it out of the way. It's like taking this and just picking it up and putting it up here to make room for the 36. And we don't bother writing down the 0, because the 0 is in the same spot where the 4 would be. The 4 makes us be in the 10 place, instead of requiring a 0 to make us be in the tens place. Now, if that's said, if we prefer doing this, why am I having them do this beyond understanding, right? We're doing this because as they do it this way, they're going to say, oh, since I'm in the tens place, I know I need a 0. Since I'm in the hundreds place, I know I need 2 zeros. Since I'm in the thousands place, I know I need 3 zeros. When we get to doing 2-digit multiplication, so 487 times 36, what I'm going to be teaching the kids to do, pretend that 3 isn't even there, and do the 6 as if it is the only thing there. 6 times 7 is 42. We'll regroup. 6 times 8 is 48 plus 4 is 52. Write down the 2, regroup the 5, and then 4 times 6 is 24, plus the 5 is 29. Once we're done with that, we'll say, okay, let's cross out all that regrouping pretend that 6 isn't there, and we're going to act like that's a 30, which is the way we've all learned it. But because it's a 30, we can start saying, oh, 30s, it's in the tens place, it needs 0 before I do any of the multiplying, and that's the tie-in between doing it this way and the traditional algorithm for doing a 2-digit number. We're doing this as a scaffold to doing 2-digit multiplication. Just to finish the math problem, 3 times 7, 21, regroup, 24 plus 2, 26, regroup, 12 plus 2, 14, regroup. And just the same way they're used to adding all of these partial products here, I've got parts of my answer here. It's not a whole answer because I got to put them together. 2, 3, 15, regroup, 7, 1. So this would give us 17,532. This is a scaffold to doing 2-digit multiplication because they get used to thinking of place value requiring zeros the same way we got used to doing these placeholder zeros when we were young. And it lets us know, since I've got a lot of parts of my answer, I need to put the parts together because that's what we would do with 2-digit multiplication. On tonight's homework, basically what they're going to see is this, but in addition to this, there's questions above it on the worksheet that just say, how did you get that? And those are sort of fill-in-the-blank answers. Some kids get overwhelmed by seeing that, but if they kind of do this section first, that can help them go back and say, oh yeah, I get a 24, and they can fill in all those blanks. That's it. I hope everybody can use this to help them with multiplying in general, and just to understand, this is not our end goal. This is, but we're using this to help us get to this. All right, everybody have a great night.